All right, so I don't know what you did this weekend, but it's very possible that you don't remember certain things from last week. That's fine. But we'd actually had a quiz, and we got the quiz back, and it had powers of 10 on it. It had metric to metric conversion. It had scientific notation on it. It had calculations with scientific notation. Remember that? So that's on the quiz, and you can study that. And then we started something different, and it's this thing right here called significant figures. Now, if you like science or engineering, this is what's going to happen. You can't get away from this. If you go to college and take a college chemistry class or physics, this is going to be one of the first chapters. Get that? Because they know that not all, but a lot of experiments are what they call quantitative. And the other word would be qualitative. Now, qualitative, I think did I give you the example about the person being pulled over and it was cocaine? So if somebody got pulled over and there was a white bag of white powder in there, and the police said, I wonder what that is. And they would have a kit in the back of their trunk, and they would pump a little hole in it and get a little bit out, and then they put a couple drops of this chemical on there. And I don't know if it's still purple, but if it changes purple, you're going to go to jail. Now, the officer is not a chemist. All they know is that when that chemical turns purple, that means you had cocaine in there. Now, that's a very qualitative analysis. It simply says, that's cocaine. That's all. Then they would take that and they'd give it to a police lab, and there would be real scientists working with almost $1 million machine called a mass spectrometer. And they would analyze that cocaine down to every detail. If the person who made it, if there was an impurity in their glassware, it would show up. They say, hey, you know this? See that quantitative analysis we did on that cocaine? It matches the people we found last week. They must be getting it from the same dealer. You see that? And they can do stuff like that. When you start associating numbers, measured numbers to it, then it becomes a quantitative analysis. When I was in college, I had to take 5 semesters. That's 2.5 years of chemistry, okay? And I was a biology major, and I still had to have 2.5 years minimum of chemistry just to get my biology degree. Well, anyway, one of the classes I had to take my junior year is called quantitative analysis, and I had never even heard that word before. And I said, I thought I was supposed to take chemistry. And it was chemistry. It was called quantitative analysis. It was all about measurement. It was all about how do you know the number you're getting from that machine, that instrument is correct. When the doctor wants to have a sample of your blood, and they send it off to a lab, and they said, you know what? Your iron levels are low. How do they know that? They talk to the little piece of blood, and they say, how's your iron? No. They put it in some kind of instrument, don't they? But how do they know that the instrument is given the right number? And that's what they were talking about in chemistry. When you get data, measured numbers, how can I trust them? Can I trust the numbers you're getting? If you don't know anything about measurement, I don't even trust your numbers. So I was trying to tell you this before. This is weird because in math class, your teacher won't ever talk about this kind of stuff. In math class, they use perfect theoretical numbers. 3 centimeters in math class is 3.000 to infinity. It has an infinite number of sig figs. It's perfect. There's no error. But when is 3 centimeters not necessarily 3 centimeters? When it's measured. The other day we had a line, and we measured it, and I don't have the same line here, but we had a line here, and in one class it was 0.3 decimeters. Another student thought it was 0.4 decimeters. All right, who's right? Well, the ruler, it only had lines like this, and they had to make a guess, didn't they? And it says here that whenever you are measuring something, you have to use sig figs. And sig figs include all the numbers you're certain about. What makes you certain? What makes me certain? The lines. The lines make me certain, but it also includes one uncertain. One of them you had to guess. So when I see this, I don't trust this very much because I know they did a good job measuring. I just don't trust it because it tells me that was a terrible measuring instrument you had, isn't it? How do I know? You only had one sig fig. How many of these are certain? How many of these numbers are certain? None. But all sig figs include the last number is always a guess. And you know what? If I wasn't there, I'll say, I know what your ruler looked like. It looked like this, didn't it? Here's 1 decimeter, here's 0, and your object was kind of like there, wasn't it? See, I know without being there, when you say 0.4 decimeters, let's say here, if you say 0.4 decimeters, I know what you mean. I know what your instrument was. I don't trust it that very much. And then I use another ruler, and maybe I got something like this, 4.225. What if I got something like that? What do you think? Which one of these do you trust more? Which one of these do you think had a more expensive instrument in it? It's the same question, isn't it? I trust it because it has more sig figs, and I know that this ruler, you didn't even start guessing until when? Thousandths of a centimeter? That was a pretty nice instrument you had there. So this is not a game. It's not a game to play. Every engineer and every scientist in the world who knows about measurement, they know about significant figures. Why doesn't the math teacher know about it? Because they don't use measured numbers. They use perfect numbers. You get it? Okay, so what do we say that all measurements have in common? Take any measurement in the world. They all have a number, they all have a unit, and they all have error. There are people on this planet, they have atomic clocks that go down to a millionth of a second. Now you and I, our world doesn't matter about millionths of a second. But some people do experiments where millionths of a second is too big. And they're trying to make a clock that can measure to 10 billionths of a second, 100 billionths of a second. And even then, it's going to have error, isn't it? Now, you and I can live with that kind of error. We can live with tenths of a second error, can't we? I'll put in the microwave 35 seconds. It was really 35.2 seconds. It didn't matter that much to it, did it? But you know that every one of you use your phone for locations like GPS? Did you know that the signals being sent from your phone to a satellite, one there, and one there, and one there, and all three of these signals, they have to know exactly how long it takes to go there and come back? And when they do, they'll say, now I know where you're at. And those probably do take, and somebody wants to look this up for extra credit, at what level of timing does GPS have to be at? What's the level of significant digits, for example? Is it millions? Is it hundreds of 100 thousandths of a second? What level of timing does GPS require to give you a location? It used to be, when they first came out, the first GPS things, they could tell you within a quarter of a mile where you were. Wow, that was fantastic. In the whole state of North Carolina, they know within half a mile where I'm at. Is that the level we're at now? No. They know, like, within a meter, within 2 meters, probably within 2 meters, they know where you're standing. Now, that's what I tend to think about. Our world doesn't have to run on millionths of a second, but some people do. Okay, so just trust me that significant figures will explain many things to you in science. For example, this. Hey, I saw this in math one day, and then I saw this in math one day, and then I saw this in math one day. And the teacher told me it doesn't matter, they're the same things. Okay. Hello. I think she was in my last period class. Yeah, sorry. Bye. Where's they at? What was I saying? Oh, I know. Have you ever had a math teacher say, hey, don't worry, it's the same thing? Well, it is. In math class, it is. If these are numbers I use in math class, there's no error anyway. And what about a calculator? By now, have you learned that if you need to put 3.00 in a calculator, you can put 3 and get the same answer? So how am I trying to convince you that there's a difference? And the difference comes in to this. What if I'm a science person or engineer and I see that you write 3 centimeters? What do I think your instrument look like? 0, 10, 3? You had to guess the 3, didn't you? What if you tell me 3.0? You're telling me what the instrument looked like, didn't it? You had an instrument like this. 0, 1, 2, 3, 4. I knew you were certain about the ones place, and then you guessed. You guessed the tens place, and you guessed 0. I know you had a better instrument there. And so it doesn't matter in math class, but in science, it's you and I talking. This is a better instrument than that. You get it? Now, where does that come into play? All right? So what happens is your book has, in the section called Significant Digits, it'll say, here are the rules. Now, I've been teaching this a long time. And when I first started teaching it, they had 7 rules. And I used to, when I first started teaching chemistry, I remember talking to some of the teachers at Grimsley. They say, I hate teaching this. Why? I worked so hard trying to teach them the rules, the 7 rules of significant digits, and then I give them a quiz and they miss half of them. Well, all right, when I first started teaching, I kind of did what they did. I just tried to work harder. And some teachers even had cute little stories to go along with it, okay? But then it came to me about 20 years ago. I finally know why students don't like this section. It's because they have to learn 7 rules. Here's a rule that says you are significant. Here's the one that says you are. Here's the one that says you aren't. Now you aren't. You aren't. You are. You aren't. No wonder they hated it. So what I did is, look what I did. I'm going to teach you 3 rules. 3. That's all. If you can learn the 3 rules that say you're in the club, and I know why students didn't like it, because you were teaching them what rule says you're in the club of significant figures, and this one says you're not. I don't need to teach you that. I'm going to teach you 3 rules that says you're in. If you're not in the 3 rules, you're out. That's all. I'm not going to teach you what tells you you're out. I'm just teaching you what's in. Let's look at here. Ready? See all these? We're going to do all 10 of them at the same time, and you're not going to make a mistake. Rule number 1, if you see a measured number and you see a digit that's not a 0, it's 1 through 9, you're in. Okay? Now watch. You don't have to do this, but I'm putting 1 line under there because that's rule number 1. I will never ask you on a test what rule it is. Just know the 3 rules, okay? Now watch. You're not a 0. You're not. You're in. You're in. You're in. You're in. You're in. You're in. In. Now, is there anybody in here that's going to forget rule number 1? If you're not a 0, you're in. You're significant. All right. Rule number 2. And if you become a famous chemist or scientist and they interview you, and I don't think it's going to come up, but don't ever say it was the Oreo cookie rule. I made this up. I made up the Oreo cookie rule, okay? Number 2, if you're a 0 in a measurement and you're in between 2 significant digits, it's like the cream in the Oreo cookie. You got wafer, cream, all right? If you're in between the 2 wafers, you're in. So what I'm looking for is an Oreo 0. No, these zeros are not between 2 significant digits. You're not Oreo zeros. How about this guy? Where's your other wafer? You're not trapped between 2 wafers. How about this guy? Ooh, wafer. Okay, now is that 0 is going to be in, isn't it? I'm trapped between 2 significant digits. No wonder I'm in. How about here? You're not trapped. Here? Nope. Here? Not there, but oh yeah, right there. How about there? I'm not trapped. Ah. Ooh, triple stuff. Now, is there anybody who will forget that if you're a 0 that's trapped between 2 significant, you're in? This is getting easier. How many rules did I tell you you're going to make? 3? We've done 2, haven't we? The third one's the only one you have to pay attention to, right? That's the one that people tend to forget. If you're a 0 and if you're a trailing 0, now listen carefully. A trailing 0 means you trail a significant figure. Then you might be in. If you're a trailing 0, you might be in. If you're a trailing 0 and there's a decimal somewhere in that number, you're in. Now, do you see any zeros coming after the 2 here? Then this whole thing is done. How many significant digits are in this measurement? 1. Here is a trailing 0 right here. It trails the 2, doesn't it? It came after the 2, but is he in? Yes, because I see a decimal. You are in. So how many significant digits there? This is easy. 2. Next one. There are no trailing zeros, so I'm done with this one. That's 3. Here's a trailing 0. Now, I never said trailing means trailing a decimal. No. The 0's trailing because it comes after the 1. You get it? But it happens to count because there is a decimal, isn't there? So you're in. Now, look at this one. Are these trailing zeros? Yes, they are. But they're not in because there's no decimal. Now, I'm sure the scientists don't want to play the stupid game. If I didn't put a decimal there, you lose. Okay, they don't want to do that. So here's what they would tend to do. Instead of saying, I don't want to make any confusion with you, I want to tell you about my instrument. Matter of fact, if there's only one sig fig, I know what that instrument looked like. It looked like this. 0, 10,000, 5,000? I had to guess that 5, didn't I? That's not a very good instrument. But let me show you what they would do. What they would do, because they don't want to play a stupid game. Oh, you left out the decimal. Yeah, I would just do it this way. 5 times 10 to the third. Now, how many significant digits are in 5? 1. Then there's no confusion. Look at the next guy. Ooh, that's an expensive instrument. These are trailing zeros, and there's a decimal, so they're in. Now, again, I wouldn't want a scientist to get confusing. I wonder if they think I had an expensive instrument. So they would write this. 5.000 times 10 to the third. And you see, this is what the math teacher is not going to do it. The math teacher is going to say, you don't have to write 5.000. They don't deal with measured numbers, do they? This scientist say 5.000. Wow, that's 4 sig figs, isn't it? That's what they're trying to say. They're trying to tell you, don't confuse me with having a terrible instrument. I had a really good one. All right, these are trailing, and there's a decimal. 1, 2, 3, 4, 5, 6. And in here, these are not trailing. What sig fig do these come after? None. They're not trailing zeros. I'm not going to teach the ones that talk about them. All right, so there's only one sig fig there. Trailing 0, and there's a decimal. 1, 2, 3, 4. And there are no trailing zeros. What do you think? In a little over 10 minutes, I could teach you something that teachers used to spend a whole period and a half on. It's not hard if you just do it that way. Okay, so what I'm going to do now, does everybody have a calculator? Does everybody have a calculator? Okay. What I'm going to do is, we're going to go to the next page here. And again, here's something the math teacher, some of you are not going to like this page. You are not going to like this page because, and I like math. I took 5 years of math in high school. No, I didn't fail either. Okay, I took 5 years of math in high school. I doubled up, took 2 maths in 1 year. So I like math. But I never had a math teacher teach this. And I probably might have been a little angry. Because the science teacher wants me to write down something that the math teacher would not have me write down. So what we're going to do is do what I ask you to do, okay? what I want you to do is, for these problems, simply put them in the calculator and put the answer way over here in the parentheses, okay? But don't write anything here. So put this in a calculator and put it in the parentheses. Okay, I'd like you to do that. And I'll tell you what, let's, instead of doing all of them, let's do number 1, let's do number 2, number 3, 5. That's a misnomer there. 7. Let's do that. Now let's do 9. Okay. 1, 2, 3, 5, 7, 9. Oh, wait, we better do 10. Oh, yeah, we better do 10. Now, all I'm asking you to do now is to do these problems and put the answer that the calculator gave you, and that means everything they wrote down. Everything's in the calculator. Write that down. 1, 2, 3, 5, 7, 9, 10. One, 2, 3, 5, 7, 9, 10. And you're going to put the calculator answer into the parentheses box.
Mr. Feeney, I can't really see number 9.
Okay, I'm sorry. Do you have this packet with you?
Oh, I'm sorry.
That's all right.
That's-
That's okay. If you don't, I have an extra packet.
Yeah, I don't know why I've been looking at it.
That's fine. Your generation is used to looking at screens all the time anyway, isn't it? A lot of times that's where everything's at. If it's not on the screen, it's not anywhere. Okay, we'll start down here with Lacey. We'll go straight down. Lacey, Elizabeth, Danielle, Todd. Tell me, number 1, what did the calculator say as we get here? Like that? Okay, now, I'm going to show you the lesson here is when scientists or engineers use measured numbers, they have to do something that they don't do in math class because they'd be lying. Like, for example, see this right here? In math class, you would write this down. Number 1, here's another thing that math teachers don't do. Your $100 calculator did not even know that a meter times a meter was a what? A meter to the second power, also known as a meter squared, also known as a square meter. Your calculator didn't even know that. What's the matter with it? It's not used to dealing with measured number, is it? So I know that it's going to be square meters. They're measuring area. Meters are distance, but when you see a distance unit to the second power, that's not distance, that's area. If you see a distance unit to the third power, like cubic inches, cubic centimeters, it's not distance, it's three-dimensional volume. And we'll talk about that another day. Now, this is what the calculator said. If you're in math class, you better write that down, because if you don't write that down, they'll mark it wrong, won't they? Because they live in a world of perfect numbers. Now, let's go up here. Somebody way beyond me have at least a PhD in statistics. They said, the scientist said, we want to make sure when we report stuff, measured number stuff, we don't want to be lying. We want other scientists to read it and say, how much can I trust it? They say, okay, you have to use statistics. Are you guys taking AP Stats maybe next year or next year? Okay. Anyway, you'll learn a lot about statistics then. And he says, statistics are, the whole idea is to say, how much can you trust these numbers in a way? What's the chance that these numbers are real? What's the chance that they're not? Well, statistics people said, hey, you know how you multiply those and get a certain number? Look at this right here. They multiply these three numbers. They must be trying to find volume because the distance unit to the third power is volume. They're trying to find the volume. And they said, you can't write that. You can't write that down. Well, what do you mean? You can't. You'd be lying to people. You're trying to say you know the volume of that object with 6 sig figs of assurance? How many were here? How many sig figs were there? Real quickly, go. 3. How about here? 3. How about here? 2. You're trying to tell me that one of your measured numbers only had 2, and you're going to tell somebody what the volume is with 6 sig figs? That's a lie. It is. It's a lie. One of the numbers you used in your calculation, you guessed the 9, didn't you? Didn't you guess the 9? Sig figs include all the ones you're certain about, and the last one is uncertain? And so you didn't even know the 9 for sure, and you're telling me you can tell the volume? That's a lie. So somebody much smarter than me said, when you multiply or divide sig figs, you have to round your answer to the least number of sig figs. What's the weak link in here? The guy that only had 2 sig figs. So watch now, watch, ready? 1, 2. Now, when you round something to 2 sig figs, do you ever look at the next one? Ever. You have to. Usually when teachers say that, everybody says, he wants me to say no. All right. If you round to 2 sig figs, do you ever look at the third one? You have to. And if it's 5 or higher, that 8's going up. And it is. It is going up. 1, 9, 0. Now, I know what you're thinking. Don't tell me that this number rounded off to 2 sig figs is 19. If you had $188,000, it doesn't mean you round to 19, do you? No. So we still have to put the zeros in place, don't I? Everybody get that? Now, how many sig figs does this have? How many? These are trailing zeros, but there's no decimal. There's only 2 sig figs. That's right. I had it round to 2 sig figs, and I'll put my unit here, and you don't like that. You don't like that because, boy, you write that in math class, they'll mark that wrong. They'll mark that wrong in a heartbeat, won't they? They don't use measured numbers. Lacey, it's your turn again. Ready? This is what the calculator said, but tell me, what are you going to write down if you're doing science calculations? How many sig figs here? 3. How about here? What's the least number? Okay, ready? 1, 2, 3. If you round to 3 sig figs, do I ever look at the next number? I have to. If I round, it doesn't mean chop to 3. You round to 3. So if underneath my finger, if the next one is 5 or higher, that little guy's going up by 1, isn't he? Let's watch. Not big enough. Not big enough. Okay, not big enough, was he? So when I write my final answer, now some of you aren't going to like this. You're going to say, no, it bothers me to only write 3.33. It bothers me. Because that's the real answer. You're wrong. If you write this down, if you use sig figs, that's a lie. You're lying. You cannot tell me the area down to this many sig figs. You can't. Look at this. You only have 3 sig figs here. All right, Elizabeth. Calculator gave you what?
24.6428.
Wait, one more. Wait, that's too fast. 24.
0.64285714.
But the calculator did not know what is a meter squared divided by a meter.
Meter.
That's That's right. The same as x squared divided by x. See? So it's meters. That's meters. All right, now watch now. The good news, the rule for multiplying and dividing sig figs are the same. So what are you going to round to? Wait, here, Elizabeth, how many sig figs here?
4,
How about here?
2,
What are you going to round to? How many sig figs?
2.
Now, when you round to 2, do you ever look at the third one?
Yes.
You have to. I'm big enough. I'm big enough. What are you going to write down?
24.
Oh, what?
25.
Now, again, please stay with me, okay? I'm not trying to tell your math teacher wrong. If they have a class that deals with perfect theoretical numbers, they're not going to have any error. They don't have to do that, do they? But if you're using measured numbers, you can't lie to people. Look at this right here. Well, yeah, look at that. I could tell you. It's that many meters. What a lie! You're a liar. Look, that number there is terrible. You only had 2 sig figs, and now you're telling me you can't. That's a lie. All right, you ready, Danielle? What's the calculator give you on number 3?
53.21.
53.
Yes.
Point what?
21.
Now, I got a little story for you, Danielle. Not me, but these same stats people. They said, "Hey, can I use that rule for everything, every kind of calculation?" I said, "No, we figured it out. Probability-wise, no. When you add or subtract sig figs, you have to round a different way. You have to round to the least number of decimal places. That means don't count sig figs. So when I add or subtract, watch now, I don't count sig figs. This one went to hundredths place, tenths place, ones place. What's the least number of decimal places? And please, the math teacher likes to tell you that the decimals are only to the right of the decimal. That's not true. We have the decimal number system. Every number you use is in some kind of a decimal place. If the math teacher wants to tell you, I meant to the right of the decimal, that's okay. So what's the least number of decimal places? Hundredths place, tenths place, or ones place?
1.
Now, watch now. When you want to round to the ones place, do you ever look at tenths place?
No.
What?
Yes.
You have to. If you run around to ones place, you must look at tenths place. Not big enough. Not big enough. So we're going to write down, Danielle.
53.
53. What kind of units? Your $100 calculator doesn't know.
Milliliters?
Yes, a milliliter plus a milliliter is a milliliter. Ty, you getting the hang of this?
Yes.
Okay, give me the calculator hit on number 5.
6.72. 672.
Is that it?
2.
Okay, and did the calculator happen to tell you what the units were?
No.
What are the units?
Centimeters cubed.
That means they're doing volume. Okay, go ahead. I'll trust you. Let's round it the correct way.
Is it 6.7?
All right, let's try it. Ty, how many sig figs in this guy here?
2.
Yes. All right, how about here?
2.
Huh?
2.
And here?
4.
What's the least number?
2.
Okay, 2. So here's the second sig fig. I take a peek at the third one. Not big enough. 6.7. You got it. You got this, don't you? You got this. Now, by the way, I want to tell you that I don't know who does this. Somewhere in elementary or middle school, somebody does this. I don't know who does that. Oh wait, let's do it this one. Let's start again. Okay, round this number to the nearest. Round this number to the nearest. I'll just do 9s. To the nearest ones place. Okay, round to the nearest ones place. Darn it. Let's start again. Let's start all over again. 4.4999. There you go, sorry. Round this to the nearest whole number. Somebody in elementary or middle school is teaching this, it's wrong. If you tell me to round to the nearest whole number, I do have to look at tens place, but I never look past that. I'm going to round that to 4. Somebody's teaching this. That makes that a 10, that makes that a 10. That makes it a 5, that makes it a 5. That leapfrog, no. There's no such thing. Somebody's teaching, I know. If you run the Price is Right, and they said, you win this car if you tell me if this is closer to $5 or $4. If you say, that makes it a 5, no, you lose. $4.49 is not closer to $5. There is no leapfrog rounding. If you round to the nearest whole number, you're only allowed to look at one number past it. All right, let's do number 7. Let's see. Kayla, we'll just go around the corner. What's the calculator have for this one? By the way, that's stupid. There's no such thing as a cubic liter. I didn't erase that. I should have. Kayla, what's your calculator say for number 7?
37.5.
Point what?
5.
Okay. And it should have said liters divided by liters. That means they cancel out. That means there's no unit. What are you going to write down here, though?
Like for the unit?
Yeah. What are you know? I know what you do in math class. In math class, you write 37.5.
Should I just put liters?
Well, liters. This should be liters divided by liters, and liters divided by liters still cancel out. So you have no units.
Yeah. So no.
Okay, but what are you going to put for a number?
38.
All right. And what rule did you use? Okay, let's try it. It says when you multiply or divide sig figs, round to the least number of sig figs. All right, look up here. Kayla, how many sig figs are in this number here? How many? 3? What rule told you that this was significant? It is a trailing 0, isn't it? But I don't see a decimal. So trailing zeros with no decimal don't count. So how many sig figs? 2. How many here? Uh-oh. That's your weak link, isn't it? You have to round to 1. Round to 1. All right? Now, that's 1 sig fig, right? Do I ever look at the next one? Is it big enough? What are you going to write? Now, if I told you to round 37 to the nearest 1 digit, if you had $37 and I said, here, I'll just round that off and give you the right amount. I'll give you $4. You'd be all right with that? I wouldn't. Yes. No decimal. How many sig figs are in this? There's 1. Ever got that? You still have to put zeros in to keep the place value in the right place. See that? All right, number 9. Davis, what's your calculator hit on this? Number 9. Yeah.
I keep on getting like weird answers. Like I put it in twice and got to the thing.
You're not getting the same?
No.
Huh. 1.252 times 0.115 times 0.012.
Yeah, I put that in.
What do you got?
1.5598.
Anything else?
Like a
E?
yeah, E -1.
Okay, E means times 10 to the negative 1. E means times 10 to the. So the real answer was 0.15598. Did you put it in mode? There's a button called mode. The reason I don't let you use your calculators on the first test, because if you put it in mode and go to scientific, it'll give all your answers in scientific notation.
Yeah, that's
So go to mode and press normal.
Yeah, it was on scientific notation when I got it, I guess.
Oh, it was. Okay. All right, so E means times 10 to the, and after the first test, I was going to show you that, but I can't let you use your calculators because then you can do all the scientific notations without thinking. All right, so really, the answer is 0.15598. Now, what are you going to round that to? Oh, you're not getting that. Okay, now we got a problem. Okay. All right, let's try it again. Is there something, I'm not sure why you wouldn't get the same answer if you did it more than once. So you're in normal mode. Are you in normal mode?
Yeah.
What do you got?
I wanted to redo it.
What do you have? Oh, you're going to redo it. Oops.
I got point 0017277.
What's after 2?
776.
Okay. All right, now, the calculator does not know that a millimeter times a millimeter times a millimeter is a millimeter to the third power, also known as a millimeter cubed, also known as a cubic millimeter, and that's a volume. It's a little tiny volume. Everybody get it? It's a cubic millimeter. All right, Davis, what are you going to do with this number? You don't want to lie to people.
You have to do round
To what?
the 1,000.
Hey, look, no. When you multiply divide, you round to the least number of sig figs. Look up here, Davis. How many sig figs right there?
4,
How about here?
3,
Yep, how about here?
2.
2. So you have to round to what?
That's 7.
2. Now these don't count. These zeros don't count. They're not significant. First significant digit's a 1. The second one is a 7. Now am I going to write 0.0017 or am I going to write 0.0018?
117.
Well, let's take a look. You're right. See that? Have you gotten over the thing that you can write this and get it right in here because it's measured numbers? But in math class, you have to write this, don't you? Got it? They deal with perfect numbers, no error. Okay, and the last one, what's your calculator say on this one? By the way, whenever you look at a number in scientific notation, the only part you look at for sig figs is that first part.
0.895.
Wait, I'm sorry, say it again.
0.895773463.
And I know in math you'd write that down and you think, look at me. Okay, but in science you're just a big fat liar if you write that down. All right, so what is a square meter divided by a meter? Okay, and what are you going to round this to? How many sig figs here? How about here? So we're going to round to 4. 1, 2, 3, 4. Now if I round to 4, don't mean chop it. If you round to 4, you have to look at the fifth one, don't you? Oh, I'm big enough. What are you going to put? 0.8? 0.8958? Okay. All right, you got that? What do you think about that?
Do you have to add the scientific notation part onto that?
Say it again.
Do you have to add like the times 10 to the whatever?
Now, I do have to put this in a calculator. I put 1.278 times 10 to the third in a calculator because this number is big, isn't it? It's in scientific notation, right? Did you put this in a calculator? See, this number here is 1.278 times 10 to the third, which is the same as what? 1.278. See? That's the same number. So hopefully you put that number in there, or you could write it 1.278 times 10 to the third, and then you said divided by, and this number is 142.67. That's the same number in scientific notation. So if I had to say, I'm going to guess here, ready? About 1,000 divided by 100, it's going to be around 10. So your final answer is going to be close to 10. Oops. So,
I didn't put the.
okay, so what did somebody else get then? Is this supposed to be like 8.9? Okay. Okay, hey, thanks for telling me that because other people probably did the same thing. If you put in a calculator with with all this, you'll get a number closer to 9. I estimated 1,000 divided by 100. That was about 10. So I knew it was somewhere around 10 was going to be the answer. Now, if you guys, thank you for staying with me on this. I have a little question for you. Sometimes in science you have to take averages. And what if I told you that these are all centimeters, 3.05, 3.10, 3.00, and they're all measured with the same instrument. I got the same number of sig figs. What do I write down as the average? So if I add these up, I get 9.15. If I divide by 3 to find the average, I get 3.05. Now, let's think about that. Am I allowed to write 3.05? Well, first of all, how many sig figs are in 9.15? 3. How many sig figs are in 3? Wait, everybody? How many in this 3? I'm taking the average, okay? Only one? If that were the case, I wouldn't be allowed to write this down. But you know what I'm going to write down? I'm going to write this number down. Oh, no, you just broke your... No, I didn't. Where'd you get that 3 from? Did you measure that 3? No, it's a counting number. Counting numbers have an infinite number of sig figs. I got 3 sig figs, I got an infinite. What's the least number? 3. So it wouldn't make sense to not write 3.05 here, would it? So counted numbers have an infinite number. Does that make sense to you? You gotta watch out for the counted numbers like that. All right, show you real quickly, and then we'll stop today. I know that you could learn this class by just listening to me real well, but some of you, I know that if you were to read it and then listen, it would mean more to you. This picture here, be honest with me. I'm gonna turn this off.